Hi, everyone. Today we're working on lesson 1.9, so simplifying polynomial fractions and identifying whether factors are indeed factors or not. So I'm just going to do 3 slides, so this should be fairly quick. When I was looking at the Ask Me Anything page, really only 3 slides came up in that. And otherwise, it seemed like the feedback I got was that you were doing pretty well. So let's get started on that. And just a side note, or not really a side note, but the more you can go from factored form to standard form and standard form to factored form using that box, the better, the easier this unit is going to be. And we are going to keep coming back to factors. How do we factor things? How do we put it in standard form? So really get used to this box, and that the top and the side are where the factors are, and that inside is going to be where you're going to get your standard form. Okay, so with that, the request I got was on 23, 26, and 27. So let's start with 23. Okay. The whole number x-intercept is x equals 2. If x equals 2 is a root, what is the factor? All right, so if I am thinking about a graph, right, and I actually don't care what the, it could even be linear, right? So it's saying where x is equal to 2. So it just means that your function crosses your x-axis at 2. So again, it could be linear, it could be quadratic. I really don't care what type of function it is. I just care that if it's an x-intercept, oops, sorry, it crosses the x-axis at that number. Okay, so if this is your root, your x-intercept, remember that factors we've had like this, like x and then a number, right? And the way we go from the factor, so let me just write factor. Okay. And remember, we call them x-intercepts, we call them roots, we also call them zeros, because the y value here, if I were to say this as a point, the 2 would be the x value and 0 would be the y value, always at your x-intercept. Okay. So we're basically, you can set each factor equal to 0 to find your x-intercept or root. Right? So I know that if I were to solve this by setting a factor equal to 0, they're telling me, hey, the x-intercept as a result would be equal to 2. Okay, so the only thing that could be in here would be minus 2, because when I added 2 to both sides to solve it, okay, those would cancel out, and I would get x equals 0 plus 2 is 2. So if the factor is x equals 2, or sorry, if the x-intercept is x equals 2, the factor would have to be x minus 2. All right, hopefully that helped there. And like if I had a factor, or sorry, if I had an x-intercept of x equals -5, the factor would have to have been x, sorry, plus 5. Okay, because there's that relationship that when the y value is 0, right, when the y value is 0, um, that gives you your x-intercept. That is where your x-intercept is located, when the y value is 0. So in this case, if the x-intercept is -5, the factor would have to be x plus 5. All right, so let's look at the next one. Oh, I don't know why that didn't erase. Okay. All right, let's go to 26, because that was the next one. Okay. So is it a factor? So I know that this would be a factor if, I wish I could show this whole thing. Let's see if this helps at all. Okay, so I'm just gonna rewrite this maybe. Actually, let's see. Okay, so if I know that x plus 2 is a factor, right, I'm going to write x plus 2. All right. Again, on the outside, we've got factors. On the inside is where we would have this standard form. Okay. So I can use the box method and I can put the first term, x to the fourth, in your upper left hand box. Now, if the last box, right, the lower right hand box is a negative 12 when we're done with this, then that's good. That means that x plus 2 is a factor. If it's not, if I get any other number other than a negative 12 on the bottom right hand corner of this box, then x plus 2 is not a factor. That means it's got a remainder, right? I think in some of the lessons you've heard remainder theorem. So if I've got additional numbers, right, beyond negative 12, then I know, hey, I've got a remainder here, which means x plus 2 is not a factor. All right, so let's see. So again, wait, let me see. So this should be negative 12. Okay, so again, here is negative 12, and this is what tells me, is it a factor or not? So again, if I get negative 12, I go through this whole process, I get negative 12, x plus 2 is a factor. If I get any number other than negative 12, x plus 2 is not a factor. All right, so let's kind of go through. All right, so we have x times x to the third gives me this inside x to the fourth. All right, now x to the third times 2 would give me 2x to the third. All right, now I need to look back up at that equation because I need to combine these two boxes to get what is in my original. So I have plus 2x to the third. I need to get to negative 3x to the third. All right. So actually, let me see if I can write this in here just so I don't have to keep going back and forth. All right. X to the fourth minus. All right. So again, this is my original, and this is what should be inside of the box. All right, so I've got 2x to the third. I need negative 3, okay? So I actually am going to get back to this, okay? So I'm saying, all right, 2 minus 5, and you can check that in your calculator. 2 minus 5 would give me this negative 3. And again, they're x to the third terms. Okay, so 2x to the third minus 5x to the third gives me this negative 3x to the third. Okay, now that I have that, all right, so I know x times negative 5x squared. Cool. So negative 5x squared times a positive 2 would give me a negative 10x squared. All right, and so now I know that this has got to combine with its diagonal right here to give me the x squared term in this. And I'm looking, I see an x to the fourth, which I got here. I see a negative 3x to the third, which I got here. I don't see an x squared term. So if you don't see an x squared term, you can use a place, actually this is probably not the best place to put this. Okay, let me erase this. All right, so if you don't see a x squared term here, you could just kind of put a placeholder 0 x squared. So that means I don't see any x squared, so I want 0 of them. All right. I basically want to cancel this out. All right. So I've got negative 10x squared. I need a positive 10x squared to cancel out. All right. So now I have x times a positive 10, right? Just making sure I'm doing that right. So 10 times x gives me 10x. Okay, wait, I need another x here. So 10x times x gives me that 10x squared. Cool. All right. Now 10x times 2 gives me a positive 20x. Okay. And I need a negative 16x. All right. So 20. I think that is um, negative 36, right? So 20 minus 36 x, okay, 20 minus 36x would give me negative 16. So in your calculators, do that. 20 minus 36 gives you 16. Okay, so now let me do this. I already have the x, so I just need minus 36. Okay, negative 36 times 2, I believe, is negative 72, right? Okay. Oh, and look, I put the negative 12 here. We actually didn't need this box at all. Okay. So now I'm going to say, wait, is this a factor? So I'm looking here, and remember, I need negative 12. So just based on the fact that this is not negative 12, it's negative 72, I can say that this is not a factor. Okay. So this is absolutely not a factor because of that. So, and just a side note, because I know that they do this in other problems, if I were to write this remainder, I would write this remainder over x plus 2, right? So actually, I won't go into that in this slide. Let me just keep it on this one. Right. But I do believe that you are told how to write a remainder. All right, so same thing here. Is this a factor? Is x plus 2 a factor of x to the third? I'm going to do exactly the same process. And the same thing, is my last term, right, that I end up with in the bottom right-hand box, is that negative 12? If it is, great, x plus 2 is a factor. If it's not, no, x plus 2 is not a factor. All right, so again, factors go outside of the box. So I'm going to put this x plus 2 here. Inside of the box, I'm going to just do that same thing where I'm just writing it here. All right. Okay. All right. So I'm going to put the first term, right? Especially since this is the like product part of it. I'm going to be putting all of this inside of the box. And what goes on top will tell me my other factor. All right. So here we go. Sorry. Okay. So I'm putting first term here, x to the third, x times x squared gives me x to the third. And feel free to pause this and see if you can finish it on your own and then unpause. X squared times 2 gives me 2x squared. Okay, now I know I need negative 3x squares. Okay, so, oh, I kind of did something similar, right? 2 minus 5 gives me negative 3, and this is an x squared. Cool. Now, x times negative 5x, right? Negative 5x, right? Because x times x is x squared. Okay, so I think that's right. X times negative 5x is negative 5x squared. All right, negative 5x times 2 is negative 10x. Okay. And now I know I need negative 16 x's. So I have negative 10. I need to subtract another 6. And again, use your calculator. Negative 10 minus 6 gives me this negative 16. Okay. And it has to be an x term. All right. So x times negative 6 gives me negative 6x. And negative 6 times 2 gives me negative 12. Okay, so I look right here, that is the last term. They have negative 12. So because that matches, we're good. Okay. Um, so yes. So x plus 2 is a factor. All right. Okay, I think that was actually the last one. So I hate writing. This might take a little longer, but I will show you how to write the remainder out. If you want to stop the video now, that's great. If you want to know how you would write the remainder, then just kind of stick around. Okay. So if I have my original, and if you think of a factor of 10 is like 5. 10 divided by 2, 10 divided by 5 is 2, right? Factors don't have remainders to them, right? It's not 5 remainder 1, right? 10 divided by 5 is just 2, right? It's just a whole number. So that's what we're kind of talking about here. So just kind of like 10 divided by 5 equals a whole number, right? That's why we call them factors. If I had like 10 divided by 3, right? Then that would give me 3 goes into 10 3 times, right? And that would be 9, and it would have a remainder of 1. So think back to your like long division days. So that's basically what we're talking about, where this is not a factor and 5 is a factor. All right. So in the same way, if I'm writing this out and I'm just writing the original, and it just takes a while because this takes a while. 16. Okay. It means that when you divide this by x plus 2, you would equal x squared minus 5x minus 6. So you wouldn't have any remainders. Like this is, if you multiply x plus 2 times this, you would get what's in the numerator. Just like if you do 5 times 2, you would get the 10 in the numerator. All right. Let's just go back to the last one for a second. So here, remember, it doesn't match. It should be 12 and it's 72. All right. So let's see. Okay, sorry, I paused it by accident. All right, so in this one, if I'm writing it out, this was my original, the x to the fourth, right? See, here's my original. So I'm just going to write that. And I'm going to divide it by the factor. Oops. There we go. 4 minus. Okay, so here's the product, like the 10 in the last example. And again, if I divide 10 by a factor, I'll get a whole number, right? Whereas if I don't, then it will be a decimal, or in this case, we're not dealing with decimals, we're dealing with what we call a remainder. All right, so if I'm dividing that by x plus 2, I am going to get um, this other factor, right? So x third, all right, 10x minus 36. Okay. And now I have, oh, why did I press? Oh, yeah, 36 from here. I was looking at the 72 for a minute. All right. So now the question is, well, how do I get the 72 to become a negative 12, right? I have negative 72. What do I either have to add or subtract that to get negative 12, which is what I have in the problem, right? So I have to really add 60 to that, right? To change it into a negative 12. So I'm going to put plus, and I might run out of room here, but I'm going to be doing plus 60 over what I divided it, or what the original factor that they gave me was. So x plus 2. Okay, so hopefully you can see that. So that's how you would write the quotient, or the result when you divide, if you have a remainder. Okay, so again, this remainder right here means x plus 2 is not a factor of the numerator, x to the fourth minus 3x to the third minus 16x minus 12. Okay, so this not a factor, a factor. All right, that's all I got for you today. I will try and have the third one soon. Again, remember next week, Tuesday, Thursday, come just right after class, like 2:20, come to B17. And come with your questions, or even if you just want to do your work there, and then as the questions come up, I will be around for support. All right, that's it. Have a good night, morning, whatever time it is that you watch this.